Welcome, this is Integral Calculus module. So we did differential calculus before. We will do integral calculus in this module and pause our introduction to differential equations. So this module, it has two lessons. Lesson one, basically, like in post lesson, what we will be doing, we will be doing something called like analytical solutions. In lesson one, we will mainly look at closed form solution. In lesson two, we will look at something called infinite series solution. And that is basically you need to know this knowledge for solving differential equation, either using infinite solution or closed form solution, as I will be showing you in this video. These are some books if you want to do additional practice. These are just suggestions. You can use these books or any similar book you have, not necessarily these ones. So let's start with lesson one, the fundamental of integrals. So part one is integration rule, same as we did with derivative. We just learned the basic rule. So basically that would be a refresher if you took Calc 1 and Calc 2 before, and would be new information if you have no prior calculus experience. But for both cases, whether this is new or whether this is a refresher, it would be what you will be doing would be good practice for FE exam. So I have several FE exam problem for you to solve. Integration, that is integration, that is the inverse operation of differentiation, and there is a rule for this. Let me just put it here for you. Okay, but I mean you don't need this rule actually, because let's just see. Let me show you. So we have already known this from previous lesson, like the fundamental theorem of calculus. So let's say I have this function f of x is equal to x plus 4x minus 12. So I have like this function. What is the derivative of this function? You are now expert in this. You will multiply this by 3 and you will subtract 1 from here. Yeah, plus you multiply this by 1 and you subtract 1 from here, and plus 0 because that's a constant. Okay, so what we did here, we differentiate this guy. How can I recover the original function? Like if I have this guy, can I know this guy? Yes. If I integrated this guy, I will get this guy. So remember, that was the fundamental theorem of calculus. So I told you like f of x is equal to the integration of with respect to dx. That will give me my f of x. Okay, so let me show you like how to integrate this function. So I can say like f of x is equal to the integration of 3x plus 4 dx. Yeah, I integrate this guy. So integration also, the integral is also called like antiderivative. Okay, so the antiderivative of this guy would be what? So let's see. So like to differentiate, you multiply it by 3 and you divide it by 2. To integrate, guess what you're going to do? You will add 1 and then you divide by 3. So the integration of this guy, that would be like 3x. You add 1 here and then you divide by 3. That's how you integrate. Plus 4, like this guy, like you can think of this guy. Let's just apply. So this is the rule here. Yeah. Let's just like this is like x to the power 0 because x to the power 0 is 1. Yeah. So you add 1, so that would be 4x, and you divide by 1. Divided by 1. Okay. Uh, but what about this guy? Like, how could we recover this guy? Actually, we can't. Like, giving the information we have, so this will go away with this will go away with this. Giving the information we have, we cannot recover this guy. So just because we cannot recover this guy, what we do here, you put a constant. So this constant would account for the possibility that there is a constant here. And if this constant here is, if there's no constant, then this constant will be equal to 0. Yeah. So when you do, when you integrate a function, you put like a constant here. That is called like indefinite integral. Uh, but how can we recover like this constant? Like, can we know what this constant is? We can actually, if we have additional information. So we will do this like when we get to the modeling and how to solve differential equation for modeling, we will see how this additional information could be like initial condition of your model or boundary condition of your model and things like that. Yeah, that is like the additional condition. So like let's see how can we recover this constant. So to recover this constant, you need additional information. So the additional information we have here, let's put this additional information that we have here. We have this additional information that here's the additional information that we have that at x equal to 2, f of x is equal to 4. That's the additional information that we have. So let's just apply our additional information. So that's like our function f of x, x plus 3 plus 4x plus this constant. Now let's apply the additional information. So here that's equal to 4 at x is equal to 2. So here like 2 to the power of 3 plus 4 to the power of 2 plus c. So that would be equal to 4. That's like 8 plus 8 plus c. So this will give us c is equal to minus 12. Yeah. So now my function would be f of x would be x to the power cube plus 4x minus 12. Wow, I was actually able to recover my original function here. Yeah. Using integration and using the additional information that I have, I was able to recover my original function. Okay. Uh, uh, Now this is what we did. This is like this type. This is called indefinite integration or indefinite integral because if you look here at my integration, I'm not integrating from like within a certain bound, like from 0 to 3, from x is equal to 0 to x is equal to 3. This is like indefinite. And when you do this indefinite integration, you end up with this constant here. There's other type where I can integrate with a definite integral. So this is called like a definite integrals. So in the definite integrals, uh, basically, let's just do an example and that will make it clear. And we will do an example, simple example, and then we will apply this to some FE problems. So let me do like this is my function f of x, yeah, and is equal to 2x plus 1 dx. And I want to integrate this function from x equal to 0 to x equal to 3. Yeah, so here this is x equal to 0, x equal like from x equal to 1 to x equal to 2. Yeah, so that's how I want to integrate this function. So let's do it. So how to do it? You just put like a bracket like this here, yeah, and in this bracket you put your limit like 2 to 3. Yeah, so I'm integrating this from 2 to 3. This will be no constant here. And then like you integrate this guy. So how to do this guy? So that would be x plus 1 divided by 2. So you'll have x squared here and then here plus x. So basically like the integration of this guy is x to the power x squared plus x. That's the integration of this guy. And then you evaluate this from 3 to 0. So how you do this? That see like that would be from f of x2 to minus f of x1. So that would be just put it here between brackets. So x3 to the power 2 plus 3. That's my f of x2. Yeah, here this is like x2 and this is x1. Yeah, minus yeah f of x1. So that would be like 0 to the power 2 plus 0. Yeah. So like if you did this, then you got like here 8 and you got, sorry, you got 9 and plus 3, you got 12. Yeah, so that is how you do this. Let's do an example. Let's do one more example. So here, this is one more example where we will form an integral and solve it, like not just form it, but solve it also. So find the work done to move an object from x1 to x2 giving a constant force F. So here, that's my integral. So work is equal to the integration from x is equal to 2 to x is equal to 3 to force time like my dx. Okay, that's like dx. Uh, my delta distance, because you know work is equal to force time distance, yeah, or fx, yeah. So my dx. So how to solve this? Like this a constant. So a constant you can take it out. So I can rewrite my integral as f. That's a constant dx. Yeah. Let me raise this guy here. Work is equal to force time x. Okay. Now I need to integrate this guy from this. So remember how to do it? You put like you make like this from 2 to 3. And what is the integration of dx? Like this is 1 here. So so that would be x. Yeah. So basically, this is equal to force time x evaluated from 3 to 2. So that would be f. Yeah. Like my force time x 2. Yeah. Minus x1. Like that would be like x2 minus like x2, which is in that case 3, minus x1, which is in that case 2. And my force is giving us 10, so that would be like 10 minus 1, so I get like 10 kilo Newton per meter. Yeah, that is basically how you can solve something like this. Okay, let's look at some FE or before this, remember integration, just to remind you, uh, derivative is the rate of a change of a function. That's what we need to learn from derivative. From integrals, we need to learn accumulation. That's or like the area under the curve, or accumulation, or depletion, or something like this. The antiderivative. So derivative, rate of a change. Integration, we learn about accumulation or depletion or something like this. So for example, if I told you what is the area that is accumulating under, like the area under this curve, like the area that's accumulating under this curve. So if I integrated this function, the integral of this function here will give me the area under this curve. Yeah, will give me the area under this curve. If I asked you what is the area between like these two curves, like f of x1 and f of x2, like this, if I asked you what is this area here, well, that is simple. Like you find the area under this guy and the area under this guy. If you subtracted this guy from this guy, that will give you this area here, yeah, which is this equation here. You can find the average value of, like, so if I told you what is the average value of this function from here to here, you can use this equation. What I told you, what is this arc length from here to here, you can use this equation. Volume, basically you integrate in this direction, and then like in the volume, then you also integrate in this direction from, I don't know, C to D or whatever, yeah? And then you get a volume. Okay, so let's you get these type of question in the FE exam. I have a few of them here for you. So I'm telling you here, delete this. I'm telling you here what is the area, what is this area here. So to find this area, you find the area under this guy, and the area under this guy, you subtract them, and then that would be the area of this shaded area. So let's do it. So and these should be like easy points in like the FE exam. Like so in the FE exam, when you get these types of question, uh, that should be easy points. Okay, so let's do it. So that would be the integration. I'm integrating from 10 to 12. So I want, because I want this from 10 to 12. So I'm integrating this from 10 to 12. What is my f of x1? Let me open a big bracket here. That would be like x squared plus 4 minus my f of x2. That's the equation of this line, minus x plus 2. And then I close this guy and I said like d of x. Can I simplify this? Yes, I can. So I can do this guy here. So that's x here, 4 minus 2. So that would be plus 2. Yes. And then minus x. Because this is minus 2, negative 2 plus 4, that's plus 2, and this negative x. And all this to the dx. Yeah. So can I solve this? Yes, I can solve this. So remember, you do this. You put here 12, you put here 10, and let's just integrate this guy. So that would be 3 over 3 minus x over 2 plus 2x. Yeah. So basically that is the solution. So now, so I have like this equation. So basically this equation, I need to evaluate this equation. Previously, like if that was indefinite integral, I wouldn't have these guys. I wouldn't have these guys, and I would put like a constant here. But since this is a definite integral, I know like my upper and lower bound, so I can just use these upper and lower bound here. Yeah. So let me just evaluate this. Yeah. So I can evaluate this guy. So that would be at my upper and lower bound. So that will be what? That will be 12 to the power 3 over 3 minus 12 to the power 2 over 2 plus 2 times 12. Yeah. So I have like this guy minus 10 to the power 3 divided by 3 minus 10 to the power 2 divided by 2 plus 2 times 10. Yeah. If you can do this with your calculator. If I did this correctly with my calculator, then I got something like this here, and I got something like this here. That's for this term minus over 3. That's for the second term. And then if you did this, then I got the final answer is something like this. Yeah. So the area under this curve is this number, like centimeter square, meter square, whatever, mile square, or whatever that unit is. Okay, so these are like some easy point in the FE exam. I have one more practice problem. Up there you will find the area under this curve. In that case, what is my second function here? So basically, the area under this guy will be this guy here. Yeah. And then what's my second function? Nothing. So that wouldn't exist. So I will only have here this one. Yeah. Because that would be this area, which is the area under this curve. Okay. Now, so try to solve it on your own. And this is a solution. I will solve it in the practice problem. Here is another one, finds the average value of a function. So try to find like the average value of a function. This is the formula you need. Try to solve it in your own. This is then look at the solution. And then this is the homework problem similar to this guy. So this is just to practice for FE. Okay. Now let's move to something else. Remember when we did derivatives, I told you like we learned the derivative of polynomial function, but there are other functions. It's not only polynomial function. We have exponential function, we have logarithmic function, we have trigonometric function, and these guys will have their uh, uh, so you can use this handy formula, because instead of like driving them from first principle, you can just use this handy formula. So I want you to pause the video just for a minute and try to like look. So this is the derivative, and these are like the antiderivative. I want you to see like the similarity, like how these like mirror to one another, like the derivative and its anti derivative. Okay, so I want you to do this, and so here like I'm just like magnifying this. So here, this is 1 over x. You got like ln x. Because remember, let me remind you of something which I showed you here. This is, oops. See, like this rule is only applicable as long as n does not equal -1. Yeah. So here, if n here is -1, and like -1, that's like 1 over x. The integral of 1 over x is equal to ln x plus c. That's like the integral of this guy. Okay, so this rule, so if you have 1 over x, you get, that's the solution here. If you got, it's like 1ax plus b, for example, then you get something that looks like this. Yeah. So these, again, all these are called like what we did before, and all what you see here, this is called like analytical solution and closed form solution, closed form analytical solutions. In the next lesson, I will show you like analytical solution, but not with this, not algebraic equation, not finite algebraic equation like this, but infinite like equations. Yeah. It's called infinite series solution. So these are some forms here. I have, you can look at more of them here. You can print this actually and bring it with you to the exam. It's just something handy if you want more of these formulas to use. Yeah. Now let's do an example. I mean, these are fun stuff. Yeah? It's just like some easy, simple things to do, and you can just do it. Like so. Let's do it here. So elementary integration of commonly used functions. So I'm telling you what is like just integrate these guys. So I will put them like, I will just do them one by one. So here's the integration of 4x dx. So you should be expert by this by now. What do you do? Like you add 1 and then you divide by 4. So that would be 4x to the power 4 divided. You, you divide by 4. And then there should be c here. I will ignore this c for now, because you see, I will just put the c at the end. Yeah, because like I'm just doing it term by term, so don't worry about this c. I'll just put the c at the end. Okay, so that will give me 3x. Yeah, because this will go with this. Just, oops, sorry, I did a mistake here. X to the power 4. Yeah, because you add 1 and then you divide by 4. Okay, let's do the second guy. So let's do this guy here. The integration of 2 dx. That is easy. Yeah, so that would be like 2x, and then there should be plus c here. Okay. Let's do the third term here. Yeah, so the third term here, the integration of plus 1 dx. Do I have a formula for this? Yeah, I have this guy here. Yeah. So I have this guy here, so that would be equal to what? That would be 1 over a, my a is 2, ln ax, so 2x plus b, which is 1. Yeah. Plus c. I mean, I don't need this constant for now. Yeah. So we have this guy here. Let's do what else do we have? let's do this guy here. So this is 1 over 4x to the power of 3. So this is a constant, so I can get like the 1 over 4 out, so that's a constant. And then I could say this is 1 over 3x, this is 1 over minus x. Yeah. So how to do this guy? So you add 1 and then you divide by negative 2. So that would be 1 over 4 x to the power minus 2. I added 1 and then I divide by negative 2. So what do I get here? So I get like 1 over 8 negative because I have a negative here, and I can bring this guy down, so that would be like x squared. So negative 1 over 8 x squared. Yeah. So I did this guy. Let's do this guy. I mean, this guy is 1 over 3x. 1 over 3, that's a constant, so I get this guy out, and then 1 over x. And 1 over x, remember, this is a special case. That is 1 over x, that's ln x. Yeah. Oops. 1 over x, so that would be ln x. Oops. So 1 over x, so that would be 1 over 3 ln x. And then there should be a constant here. Oh, I forgot to put my dx here. I forgot to put my dx here. Okay, and let's do this guy here. So this guy here, 8 over 3x dx. So that would be, I mean, I hope this is not getting boring, but so that's the rule here. So you just put like 8 over 3x over 8, 3 ln k, which is ln 8. That's something like this. So we did this guy. How about this guy? Ln 2x. So that has a rule here. So this guy has this rule here. So ln 2x dx, that will give me, that would be equal to x ln 2x minus 1. Yeah, see here, that's the rule. What else do we have? We have this guy here. So this guy has a rule here. Okay, so let's do this a little bit smaller. I can get some space here. So let's do x 3x dx. So that has a rule here. So that would be equal to e to the power 3x minus 1 over k square. That is 3 square. That's my k here. These are the rule here, and that would be e to the power 3x minus 1 divided by 9. Something like this. Okay. Oh, finally, my last one. So that is like uh, sine 2x dx. That is equal to 1. So I have a rule for this guy. Yeah, that is minus 1 over 2 cosine 2x, and then there will be a c here. Okay, so basically, like I can do this like my final answer, like if I did all this correctly, and my final answer, I just want to copy it here, with my final answer would look something like this. Uh, oh, it's easy to make mistakes in these things. I just spotted some mistakes while I was copying this. So I was just correcting them. Okay. So we put also this integral would be, let's see, let's see what we did correct and what was not correct. So we got this guy, we got this guy, we got this guy here. We 1 over 3 len x, where is this guy? Yeah, we got this guy here correct, yeah. So we got this guy here, it's here. We got this guy, oops, we got this guy here, which is here. We got this guy here, which is here. We got uh, this guy here, which is here. Got this guy, and then you put your consonants again. Okay, so that is, I think, yeah, that is, let me delete this. I already showed you because I could have it. So this is the uh, practice problem. I will solve this in the tutorial. So try to solve it on your own. This is the solution. This is the homework problem. Again, easy, simple stuff. So that's all for this video, and see you in the next video.